So last time we learned how to check the number of each type of element on both sides of the reaction. Sometimes you actually have to balance these equations. Remember, you have the subscripts, which you cannot change. This tells us what we have, these subscripts do. The only way we can balance these equations is by putting numbers in front of each element or compound. So if I look at this, I have 1 potassium on the reactant side and 2 on the product side. What do I place in front of this potassium to give me 2? What times 1 gives me 2? Yeah, 2. So now my potassiums are balanced. Here I have 2 borons on the reactant side. On the product side, I just have 1. What do I need to place in front of boron so that it's balanced? What times 1 gives me 2? That's also a 2. Here I have 3 oxygens. On this side, I only have 1. So what do I need to place in front of this one to give me 3 oxygens? What times 1 gives me 3? That would be 3. But now that my oxygens are balanced, what happens to my potassium? I have 3 times 2, which is 6 now. On this side, I still have 2. So now I need to erase that 2. If I have 6 over here and I have 1 here, what times 1 gives me 6? I put a 6 there. Now I double check. Am I balanced? So let's come and I will double check everything. I have 6 potassiums. 3 times 2 is 6. That's good. 2 borons. 2 borons. That's good. 3 times 1 is 3. And 3 oxygens. Now we're all balanced. We have obeyed the law of conservation of mass. We're good. Let's check this one. This one's a little different. We see we have oxygen, oxygen, and oxygen, and oxygen. Oxygen's in 2 different places. So I'm going to save that until last. And if I balance everything else correctly, those oxygens will end up balancing themselves out. Hydrogen's in 2 places here as well, so we'll leave that one until next to last. So let's look at the phosphorus first. So I'm going to look here, and I have 1 phosphorus here. Here, remember, this gets distributed inside the parentheses. So I have 2 times 1 is 2. On this side, I just have 1. I need to put a 2 in front because 2 times 1, because remember that will get distributed there. Now I have the same number of phosphorus. Oxygen I'm leaving to last, remember, because it's in 2 different places. And I know if I change something else, it's going to have to be changed. So let's try to balance everything else and then come back to it. So magnesium right here, I only have 1. Here I have 3. So what should I place in front of magnesium? A 3. 3 times 1 gives me 3. So now my magnesiums are balanced. Now I'm going to go to my oxygen or hydrogens and balance them. Here I have 2 times 3, which is 6 hydrogens, plus I have to put both of these distributed. So this is 3 times 1 times 2. So that's 6. So I have a total of 12 oxygens or hydrogens on the reactant side. Here, I only have 2. So what times 2 gives me 12? That would be 6. So let's look at this. Now, if we did this correctly, we should be balanced. So let's see how correct we are. Let's look at our oxygens now. We have 2 times 4, that's 8, plus 3, because that gets distributed, times 1 oxygen, times 2 oxygens. 3 times 1 times 2 is 6, for a total of 14. Here we have 2 times 4, which is 8, plus 6 times 1, which is 6, which is 14. So we have correctly balanced this equation. Still the same process, but you're just adding a little bit of math to it. You're checking to seeing what you're doing, trying to make sure you have the same number on each side. Now that we've learned to balance equations, we need to be able to identify the types of reactions that is happening. And there are actually 5 types. You have the synthesis reaction. That's where you have 2 or more substances and only a single product. This is A plus B produces AB, basically. Here, I give you a little illustration. You have the starving bird who eats a worm as big as he is, and now he is a great big bird. A real life example, we have sulfur dioxide plus water, and this gives us H2SO4, sulfurous acid. 2 things become 1. That's synthesis. Synthesis. A decomposition reaction is the opposite of a synthesis reaction. And this is a compound breaks down into 2 or more simple substances. You have one thing, one reactant, and 2 or more products. If we break apart water into its components, that is an example of a decomposition reaction. Here, you have an egg. It hatches, so you have your turtle plus the eggshell. The third type of chemical reaction is single displacement, and that's when an element or ion moves out of one compound and into another. You have something that is single, you have a single element on both sides. It's not the same element, but it's a single element on both sides. It's like if you went to a dance with somebody and they left with somebody else. They paired up with somebody else. The person who went single is not the same person who left single. And yes, that is cold. I've been told that in my classes. Double displacement is a fourth type of reaction. And this is also known as metathesis reactions sometimes. It's just where you have two reactants trade fragments. So everybody's paired up to start with, but nobody has the same partners on the product side. So it'd be like two couples switching dance partners. Everybody's still paired, but then you're dancing with somebody else. Here, in this image, you see a man with the black hat and a man with a white hat, but they've switched hats. That's what happens here. Sodium is with nitrogen or nitrate on the product side, but sodium is with chlorine on the reactant side. It switched with silver. A combustion reaction, this is a very important reaction. This is how we drive in our cars, unless, of course, you have an electric car. But most people have cars that run on gasoline. You need combustion in order to use that fuel. If you have natural gas in your house, you use combustion. If you have electricity, the electric plant most likely uses combustion. So combustion is integral into our daily life, whether or not we realize it. And that's where a substance reacts very rapidly with oxygen, and it forms one or more oxides. Carbon dioxide and water are the results. So you're always going to have carbon dioxide and water. And it's only carbon dioxide and water that are the results. So you have to keep in mind when you're looking to identify if it's carbon dioxide and water plus something else, that is not a combustion reaction. It might be an acid-base reaction, but it's not a combustion. A combustion will only have carbon dioxide and water as its products. All right, let's do some practicing. What type of reaction are each of these? And I want you to try to answer them and then come back and check them and see if you got them correct. So if we look at this, we have two separate things. A plus B produces C. What type of reaction was that? We have two things becoming one. That's a synthesis. So for our next one, what type of reaction is this? We have one thing breaking down into two or more. This is actually the opposite of number one. That's like your egg hatching into the eggshell, of course, and the turtle. So that's your decomposition. It's breaking down into pieces. For three, we need to check and see what type of reaction this is. This actually isn't a great example, I just realized, because you have a single thing here. But this actually is you're reacting a hydrocarbon with oxygen. And what are your products? Look and see what your products are. Carbon dioxide and water. If your products are only carbon dioxide and water, it is a combustion reaction. We're going to do another one, another set of problems, and then we'll be done for the rest of the night, but what type of reaction is this one? You have something single here and something single on this side. These two are paired and these two are paired. So what happened? The single displacement. For the last one, what type of reaction is this? You have silver nitrate, but on this side, you have silver with chloride. On the reactant side, sodium with chloride and sodium with nitrate. So everybody's paired up. The products are not water and carbon dioxide, so it's not combustion. It's not breaking down. This is double displacement because you started with everybody paired, but at the end, everybody's with a different partner. All right, you guys did a great job, and we'll see you next time.